this is Michelle. So this video is for Calculus 3.3. It's on increasing and decreasing functions. We've already looked at them numerically, where we make the number line and we do our pluses and minus evaluation of the derivative. We've done a little bit of numeric tables. Now we're going to do graphic examples, where we look at a graph of f prime and we determine where f is increasing or decreasing. All right, so you can come on in, it's fun. That's cool. And we're going to go through 9 different AP questions. All right, so we have this graphic example. So the graph of the derivative of a function is shown. All right, so for me, I just find it helpful to really, it's labeled for us, but I'll just put a big F prime here, and I suggest that you annotate that with a big F prime to indicate to yourself that every time you look at this, you're not looking at F, you're looking at the derivative of F. Like, you're looking at F's derivative. Which of the following statements must be true? There exists a local max at 0, okay? There exists a local maximum at 2. The F is increasing for all x is less than 0, etc. Okay, so let's annotate each of these. So if there exists a local maximum, what has to be true about f prime? Since I'm looking at f prime, I'm going to translate in my head from f to f prime. So if f has a maximum, f prime is changing from positive to negative. Positive to negative. So just to review, positive is, this is positive. Positive is above the x-axis. Negative, this is negative. So if you're changing, if f prime is changing from positive to negative, what this is going to look like is that. You're going from above the x-axis, to below. That's what changing from positive to negative looks like. So if we look here, are we changing from a positive y value to a negative y value? No. Okay? So if this were a graph of f, this would be a max. This is not a graph of f. It's a graph of f prime. I'm not changing from positive. So let's go. Okay? There's just a local maximum at 2. So same thing. F prime changes from positive to negative. Let's check that out. Are we changing from positive to negative here? Yeah. Yep, we sure are. So this is going to be my answer. All right, this one, f prime is increasing for all of these values. This would mean f is increasing. That would mean f prime is positive. Is f prime positive in this whole region? No. Okay. So again, if you look at this, f would be, if this were f would be increasing. If this were f would be increasing. This is not f. This is f prime. F prime, for f to be increasing, f prime would have to be positive in this whole region. F prime is negative here, so that's the problem. That's why that's false. All right. Let's move on. Okay, the next ones you guys are going to try on your own. All right. We have a bug begins to crawl up a vertical wire at time t equals 0. The velocity at the velocity of the bug at time t between 0 and 8 is given by the function whose graph is shown above. So this is where I annotate. I'm going to say this is velocity. At what value of t does the bug change direction? Change direction. So I'm going to annotate this. What does change direction mean about velocity? Come on in. What does change direction mean about velocity? So go ahead and annotate it. Annotate this and come up with the answer. Put it in. I'll give you a sec and then we'll join back up. Alrighty. It is 6. So the annotation would be velocity changes, when you changing direction, velocity changes sign, S-I-G-N. So you're changing from positive to negative or negative to positive. It's also known as an x-intercept. Velocity is an x-intercept. Now, just to let you know, if it had gone like that, you're not changing direction here. You're going through 0, but you actually have to change signs to change directions. This would not be a change directions. But at 6, it is. All right, let's do this one. APQ 9. The graph of f prime, I'm going to put a big F prime here. The graph of f prime, the derivative of f, is shown in the figure above. Which of the following describes all of the relative extrema of f on the open interval a to b? So let's look at relative extrema. Relative extrema of f means certain things about f prime. So relative extrema is like maxes, relative maxes, relative mins. So if f has relative extrema, what does f prime have? What's it doing? What's f prime doing? So think about that. Look at your graph. Figure this out. I would annotate first again. What does this mean that f prime is doing? Okay. Just justify first, and then come up with your answer. All right. We'll give you some time. All right. So this means your annotation should be changes. Changes, you could say changes from positive to negative or from negative to positive, in the case of max and a min. So I'm just going to write changes signs, okay? This is also known as crosses the x-axis. You could also say f prime has x-intercepts, but it's actually crossing through. It's not bouncing off, it has to be crossing through. So you can't be bouncing off, you have to be literally changing from pos to neg, neg to pos, not just any old x-intercepts. So that's here, that's here, that's here. This is negative. And then it's positive. So think about which one, max or min, changes from positive to negative. Which one, a max or min, changes from negative to positive. From negative to positive, that would go from decreasing to increasing, so this is a min. So it would be a max, because this is pos, and this is neg, and this is neg, and this is pos, so this would be a min. So the answer is A. We have one max and two mins. ABQ 10. All right, let f be the function defined and continuous on the closed interval from a to b. If f has a relative maximum at c, where c is in that interval, which of the following statements must be true? So f has a relative max, and I'm continuous, okay? I'm continuous. Which of the following statements must be true? The derivative exists. If the derivative does exist, then the derivative is 0. If the second derivative exists, it must be less than or equal to 0. Ooh, this is a kind of a tricky one. Let's go through number 3 together, and then I'm going to have you determine the answer from there. But let's talk about the second derivative, okay? So the second derivative, so f prime indicates concavity. The sign of f prime indicates concavity. Right? We're going to learn more about this later. This is really 3.4, not 3.3, but this is like a little preview. Remember, so concave up. Hi. It's like this. Hi, you can come on in. And concave up is like this. And so you have f double prime is positive, and concave down is like this, and f double prime is negative. So if this is less than or equal to 0, you have the second derivative being negative, which means you're concave down. Second derivative negative, concave down, means you're a frown. So does that correspond to having, if you're a frown, do you have a relative max? Yes. Okay. Again, more on that later. But what I'm really interested in is 1 and 2. If you have a relative max, 1, does f prime have to exist? 2, if it does exist, does it have to be 0? Okay, so knowing that option 3 is true, go ahead and choose your answer. And we're back. All right, so the answer is E. F prime does not exist because at a relative max, f prime could be 0 or it could be DNE. It's going to be one or the other. So it doesn't have to exist because it could be DNE, but if it does exist, if it's not DNE, then it must be 0. That's the only other option. All right, moving on. Moving on to 11. Yeah. Sec here. All right, so we have f prime and g prime exist then f prime is greater than g prime for all real x. And the graph of y equals g, which of the following? So they intersect exactly once, no more than once, not intersect, could intersect more than once, or have a common tangent at each point of intersection. So I'll give you some time, think about that, and then we're going to come back together. Jamie's here. All right, and we're back. So you have this derivative, so I have this derivative is always greater than that derivative. I can think of a simple line case if I have, the slope of 3 versus the slope of 2. Do you want to know the answer? Let's go over the answer real quick. It's A. So if you got that and you feel good about that, you can move on. But let's say if I have a slope of 3 versus a slope of 2, they have to intersect. They have to intersect. The slopes are different, they're going to intersect somewhere. But the thing is, if this is always bigger, if this one's always bigger everywhere, you can't be doing this like this curvy pattern here. If it's always bigger, you have to be monotonic. You have to be like increasing the whole time kind of thing. If you have another thing that's increasing the whole time, for instance, but at a lesser rate, something like, I'm trying to make it flatter here, like a lesser rate, it's gonna have to intersect more than once. It's a little tricky. But the point is that if you start getting all curvy, you're not gonna have your derivative be greater than the other one the whole time. You have to be monotonic. You have to be strictly increasing the whole time or strictly decreasing the whole time.
No terms.
No terms. No terms. All right, let's move on. We have 4 questions left. 4 questions? 4 questions. All right, the graph of the derivative is shown above. So what do? We annotate. Oh yeah, it already says f prime, but we're going to annotate it anyway, really big. All right, the graph of the derivative is shown in the figure above. Which of the following could be the graph of f, the original? So there's a couple different ways to do this. You could say, I'm the derivative, what are my special points here? Let's find the original. Or you could do guess and check, say like, let's pretend this is the original. Let's take its maxes and mins and see if that corresponds. So I would maybe think about these points on f prime and these points on f, but these are all f here. Okay, so take a sec. Take some time, try to figure it out, and then we're going to come back together. And we're back. All right, the answer is coming. The answer is, it is B. It is B. So this for f prime, when you are going from positive to negative, that means you have a relative maximum at that point. So at -1 exactly, you have a relative max. That's here. That is not this guy. This would be a relative min. Okay? But it's not these. One of these, this is the derivative of that, but this is, if you chose D, you figured this was the original function and this was the derivative, which is wrong. B, this guy's the original, that guy's its derivative. Cool. All right, moving on. We got APQ 13.
I love this.
These are fun.
I love this.
They're very great. All right, the graph of f is shown above. Which of the following could be the graph of the derivative of f? So since we did the last one together, I'll just annotate for us. The graph of f is shown in the figure above, so we're going to label this f. Which of the following could be the derivative? These are all f primes. Okay? So you want to think about corresponding maxes and mins to positive changes to negatives. You know what I mean? So I'll let you think about that. Alrighty, and we're back. So the answer is, drum roll please, it is A. Okay? So I would identify this as a maximum of my original, and then so for the derivative at that point, right here, at the derivative right there, your derivative should be changing from positive to negative, which it is. positive, negative. It means above the x-axis, below the x-axis. Is this doing that? No. Is this doing that? This would be a min of f. Is this doing that? No. This is doing that. But to get a line as a derivative, you would have to be starting with a quadratic. This isn't. It's a trig function, actually. This is like a sine, cosine thing. All right, let's move on. ABQ 14. All right, the graph of y equals h of x is shown above. Which of the following could be h prime? So again, we're thinking maxes and mins. Go to changes from positive to negative. Take a sec. Do it out. And we're back. The answer is E. So this maximum goes from positive to negative here and negative to positive there. And that means this one's also doing that, but this is a cubic and this derivative is going to be a quadratic. This is like a negative cosine. This is like a this is a sinusoidal function, which is not going to be the derivative of the cubic. We can do a further analysis, but it's fine. Whew, alrighty, this is one of my favorite questions. One of my favorite questions and our last question. All right, it's also a little tricky. Which of the following pairs of graphs could represent the graph of a function and its derivative? So it has it annotated. This is f, this is f prime, this is f, this is f prime, this is f, this is f prime. Okay? So you want to kind of use maxes and mins here. Some of the graphs don't have any maxes and mins. Like this has a max and min, that's nice. But this one, for instance, doesn't have a max or a min. So you want to think about, like, just in general, besides the maxes and mins, you want to think what the slope of f has to equal, the slope of f has to equal the y value of f prime at any given point. This is a key of how we move beyond the maxes and mins, okay? This is the key of how we move the maxes and mins. So like, for instance, I don't know, for this one just right here, the slope I've estimated about 3. You're going to look at the y value over here. Is it about 3? Is the y value about 3? Okay, that point works. Okay, I chose that point specifically. So you need to try some more points like on this one to see if that works, and then think about these two. You can probably use maxes and mins to figure these out. All right, so take some time and figure out the answer. This is the last one, guys. And we're back. The answer is D. So give yourself a big pat on the back if you got that. This is its own derivative. So this, I'd estimate the slope here to be about 1. The y values, about 1. Alrighty, maybe let's go over here. I'd say the slope here is like 1/3. The y values, about 1/3. Do we recognize what this is a function of?
No.
Can we name it? It's an exponential. Let's name it as e to the x. So we just learned, because the graph is the same, that the derivative of e to the x is itself. Whoa! And y is e to the x, y prime equals e to the x. Whoa! We're going to learn that later for realsies, but now it's just like a little taste. Just a little taste. This is a max. This would have to go from positive to negative. It doesn't. This has a max here. This would have to go from positive to negative, which it does. This also says the derivative of cosine, the derivative of sine, the graph of sine, is cosine. So you could have done that algebraically if you recognized what the graphs were. Probably didn't though. All right, and thanks for doing this. This will be a 10-point homework due tomorrow. Bye.
Why do I